Businesses have many variables and moving parts. Any kind of analysis with multiple variables must keep consistent in assumptions and components. In this section, we will cover the basic assumptions, formulas, and components that make CVP analysis a reliable tool for analysis and informed decision-making. Let's start with the assumptions. When performing CVP or cost volume profit analysis, the following assumptions or factors always granted as true in this methodology must be made. Number one, sales volume is the only factor that affects costs. Number two, all costs can be categorized as either fixed or variable and even mixed costs. Number three, the number of units sold is equal to the number of units produced. Number four, time value of money is not considered in this analysis. Number five, sales mix remains constant. Now, let's look at the CVP formula and define each of its components. The basic formula used in CVP analysis is as follows. Sales less variable cost less fixed cost equals operating profit. CVP analysis is very flexible. The basic formula can be adjusted to focus on a specific factor or a combination of factors. For instance, if we want to learn how shifts in sales volume impacts operating profits, like we'll need to do in a few minutes, we'd use the following variation. Sales price per unit times number of units sold less variable cost per unit times number of units sold less fixed cost equals operating profit. Definitions of these components that make up the CVP formula shown on the screen are as follows. Number one, sales. This is the dollar value of revenues from sales. Number two, sales price per unit. That's the amount of a customer pays to acquire 1 unit of product or service. Number three, cost. This is variable or fixed expenses involved in producing and or selling a product or a service. Number four is volume. The number of units or the amount of service that is sold. Number five, operating profit, and that's the difference between the selling price of a product or service and the cost to produce or provide it. Number six, contribution margin, which is the sales revenues minus variable costs, which is the amount left over to cover fixed costs. Let's use the basic CVP formula to analyze House of Coffee's operating profit for 3 of their most popular in-store consumable products: the large cappuccino, large Americano, and the coffee puff pastry. This is a great starting point for revealing where they are now and where they want to be and how they can get there. Remember, this formula is as follows. Sales less variable cost less fixed cost equals operating profit. At a sales volume of 1 million units, the analysis reveals the following numbers for each product. As the table on screen illustrates, the large cappuccino at a 1 million sales volume brings a $7 million total in sales at $7 per unit. The total variable cost is $3 million since each unit costs $3 to make. This cost creates a contribution margin that equals $4 million. The total fixed costs are $5 million regardless of how many cappuccinos sell. For House of Coffee, this means a loss of $1 million in sales on their large cappuccino. Now, with the same 1 million in sales volume, the large Americano brings $4 million in sales for a product that costs $1 to make per unit, meaning a cost of $1 million in total. That's a $3 million contribution margin and total fixed cost of $5 million. For House of Coffee, this means a loss of $2 million in sales on their large Americano. So now we can begin to see that House of Coffee needs to have a minimum contribution margin of $5 million if they do not want a loss. Now let's see if their coffee puff pastry will cover their fixed cost of $5 million. At the same 1 million in sales volume, the coffee puff pastry brings a total in sales of $8 million and a variable cost of $6 million in total since each unit costs $6 to make. It's much more expensive to make a dessert versus a cup of coffee. The contribution margin is $2 million. The total fixed cost remains at $5 million. This means for House of Coffee, a loss of $3 million in sales on their coffee puff pastry. Where it gets interesting is where you look at the analysis at a higher sales volume. When each of these products is also examined from a 2 and 5 million units in sales volume, the CVP analysis of House of Coffee's 3 in-store products reveals that the sales price per unit, variable cost per unit, and total fixed cost remain the same. The variable that changes is only the sales level or volume. Just changing the volume of each product from 1 to 2 million and 5 million units allows House of Coffee to easily see at which volume each product will have an operating loss or operating profit. So let's hone in on the operating profit associated with each product and with a sales level of 2 million units. It shows that the large cappuccino turns into $14 million in sales minus a $6 million variable cost and a $5 million fixed cost, resulting in an operating profit of $3 million. The large Americano makes $8 million in sales, so how much is the operating profit? Well, if we minus $2 million in variable cost and $5 million in fixed cost, we are left with $1 million in profit. As far as the coffee puff pastry, it makes $16 million in sales, which is great. However, the operating profit results in a loss since the variable costs are $12 million and the fixed cost of $5 million. The loss on this product is $1 million. As you sit down with the owner of House of Coffee, you can now inform him that at 2 million units sold, the coffee puff pastry will result in an operating loss. But at the same sales volume, the large Americano and the large cappuccino will result in an operating profit. Hello, certified professional. If you are enjoying this course, get accredited with CPE credits for watching it. Click the link in the show notes or visit cpeflow.com to access the full course ad-free and pass the final assessment quiz to officially earn your NASBA approved CPE credits and certificate of completion. The owner asks you if there is a way to do the same calculation through a formula that emphasizes sales volume. And of course, the answer is yes. Yes, there is. As you'll recall, the formula goes as follows. Sales price per unit times number of units sold minus variable cost per unit times number of units sold minus fixed cost equals operating profit. A large cappuccino selling for $7 per unit times 2 million units equals $14 million in sales. A large cappuccino with a variable cost of $3 per unit times 2 million units equals $6 million in costs. House of Coffee has fixed costs of $5 million. Now, for $10 million in sales minus $6 million in variable cost minus $5 million in fixed cost equals an operating profit of $3 million. The highest profit in the CVP analysis when compared to the other 2 products. When faced with the simple CVP analysis you have presented today, the owner of House of Coffee realizes that the company should focus their frontline workers and direct on-site managers on promoting the large cappuccino over the Americano and coffee puff pastry. And this is in order to realize the greatest operating profit. Starting tomorrow, you can expect to see more of the large cappuccino on House of Coffee's Instagram page, a large promotion picture on their cappuccino on all the storefronts nationwide, and hopefully, it's a trend that online influencers will follow by flooding the web with House of Coffee's delicious and profitable large cappuccinos. With the holidays approaching, House of Coffee wonders how to price their seasonal specialty items such as their cinnamon cappuccino and orange peel Americano. Since these drinks are only made for the holidays, what is the impact on the sales volume, and can the company use CVP to define the contribution margin? Let's find out how to help House of Coffee's holiday season strategy in the next module.